to do addition of ordinates using your CAS calculator page and using the table of values function from the CAS calculator page as well. So first, let's just have a look at the question. We asked to sketch the graph of f plus g, where your f of x is your log graph and your g of x is your negative linear line. Also too, let's just have a look at a couple of notes that I put here. What I found is with regards to the domain of your resultant graph, meaning when you plus f with g together, just something to keep in mind. So if f of x is defined, the resultant graph will be defined at the domain. And as you can see here too, if g is defined, then the resultant graph is defined. However, as long as one of them is actually undefined at a particular domain, your resultant graph will going to be undefined. So just keep that in mind. Let's just have a look at our question again. So in order for you to perform this addition of ordinates to get the accurate sketch of your graph, what I would like you to do is to open up a graph page for me. So in f of 1, we're going to sketch our log graph. And in our f of 2, we will sketch our negative linear graph. Now, as you can see, looking at my two graphs here, the domain of my blue graph, log graph, is actually undefined on the negative side, so I'm not going to worry too much about this side because it starts to be undefined when the sort of like the positive side are plus. So whilst we're here, I'm going to show you how to adjust your window using, stay where you were on this graph page without having to do the long way for the window setting. So with regards to my Y max, I'm just going to keep as 5 will do, and then we're going to hit tab. And then with regards to my X maximum, let's make it a little bit big. Let's make it 15. We're going to hit tab. And with our Y minimum, let's make it a little bit smaller than that. So let's make it -10. And lastly, with our X min, let's make it say -3. That should be fine. All right, so I have a better view of my graph now. So in my f of 3, I will going to sum up f1 and f2 together. So just by using your variable button, add the two functions together. So that looks like a very nice curve there, as you can see. So in order for you to have a pretty clear or very accurate sketch of your resultant graph f of 3, what I normally do is I always call out the table values, and in order for you to call out the table values, I would like you to press Control the letter T. So by hitting Control the letter T, we have our table values. So the first column is all the x's. So by default, increments for x is by 1, and it ranges from -infinity, as you can see there, through to +infinity. So let's go back to 0. And if you scroll across, our next column will be all the values, the y coordinate of your f1. The second column will be all the y coordinates of f2. That's not my interest. My interest is all the y coordinates of our resultant graph, meaning f of 3, when we add f1 and f2 together. So now, let's have a look at when x equals to 1, what will y equals to for our resultant graph. So x equals to 1 is right here. The corresponding y coordinates, it's at 1. So that's nice and clear there for you. And then when x equals to 2, which is here, you can see that your y value is at -1.3 ... And then when x equals to 3, your corresponding y coordinate of your resultant graph is -1.19. And if I were to continue to scroll down, as x values get higher and higher, you can see on screen here that the corresponding y coordinates get smaller and smaller and smaller. And you can tell by the behavior of your black graph right here. As x gets bigger, y gets smaller and smaller. So that's quite nice there. So you can, by looking at these values, you can just basically plot a pair of coordinates at a time. To me, when I do this, I think if you were to do plotting, you need to run about at least, say, between 7 to 10 points, or maybe sometimes, sorry, not 7, run about 1 to 10 points to get a really good picture of your resultant graph. Sometimes you might need to do a bit more, but as you can see, you can do as many as you want from this table values. Now what I'm going to do is I'm going to go back to when x equals to 0. So between when x equals to 0, which is right here, and when x equals to 1, which is right here. Now as we can see, there are x values here as well. Now you can tell by just, by estimation of what the corresponding y coordinates may be, but some of you may like to really, have a really accurate sense of what these y coordinates of F3 is. In order for you to get this, increase the accuracy of getting the y coordinates, what you're going to do is you're going to edit this table setting for me. So instead of doing the default by increments by 1 for your x coordinates, we can make it by increments by a quarter or even by a tenth if needed. In this case, I think by a quarter should be sufficient because I really want to know what these value here really equals to. So in order for you to do table setting, I would like you to hit menu. We go down to number 2 where it says table, and then you go down to number 5 where it says edit table settings. Now just ignore where it says table starts. I would like you to hit tab, and you should go down to where it says table step. So the default from your calculator is table steps by 1. I don't want that. I'm going to make it 0.25. Leave the rest as it is, tap, 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 until OK is highlighted. Now, as you can see, let's go back here. My interest is just to look at the x between 0 through to 1, meaning this section here of my F3. So I can accurately sketch it. Now, as you can see, just by inspection, as x gets smaller, this region here, y also gets smaller too. And it's evident here. As x gets smaller, we're going from 0.75 to 0.5 to 0.25. Y does get smaller, so that is very nice right there. So that's pretty much the end of my tutorial. Just one thing before I go, just to exaggerate the idea about the concept that I mention over here about your domain. So just keep in mind that in order for your resultant graph, meaning f plus g, to be defined at that particular domain, both f and g must be defined. And looking at our graph here, can you see that your f of 1 is undefined at x equals 0, and any x value that's smaller than 0, it's undefined at f1. So that corresponds to the same behavior as in your resultant graph F3. So when x equals to 0 and anything that, any points, any values of x that is smaller than 0, all the way to negative infinity, as you can see, it's consistently undefined for your f of 3. So you can now be confident that knowing that there is a vertical asymptotes as well at x equals to 0 for your resultant F3. And that is the end of my tutorial. Thank you.